The second case for partial fractions is repeated linear fractions. So this time we're going to suppose that q of x contains a term of the form x minus r to the mth power. So the partial fraction decomposition will have a partial fraction for each power of x minus r up to and including the mth power. So for instance, if we have something like x minus 2 cubed, we'll have an a over x minus 2 plus b over x minus 2 squared plus c over x minus 2 cubed. So we'll look at this one. You'll notice if I factor the denominator, I get x squared, x minus 2. So setting this up, 5x squared minus 3x plus 2 over x squared, x minus 2 will be, well, we'll notice that x is the repeated factor here, so I have to have an a over x and a b over x squared. And that's as far as I need to go since this term is only squared. I also need a c over x minus 2. And now we'll multiply by the denominator of x squared x minus 2. So I get 5x squared minus 3x plus 2 is equal to ax x minus 2 plus b x minus 2 plus c x squared. And we'll start by using the same method we were before. Let's see what happens when x is 0. On the right hand side I get a 2, and on the left both the a and the c terms cancel, and I get negative 2b. So we see that b is negative 1. If I let x be equal to 2, on the left, I would have 2 squared, which is 4, times 5, which is 20, minus 6 is 14, plus 2 is 16. You'll notice the a and the b term cancels, and I'll have 4c. So c is 4. However, you'll notice there's nothing we can stick in for x to make the b and the c terms cancel, but not a. So we'll have to do that one a different method. I'm going to start by actually multiplying out the right-hand side to get ax squared minus 2ax plus bx minus 2b plus cx squared. I'm then going to start regrouping things on the right-hand side. So you'll notice we have an ax squared and a cx squared. So that's the same thing as saying a plus c x squared. I have a minus 2ax and a bx. So minus 2a plus b x. And then I still have this minus 2b term. And at this point we can set coefficients equal. I can look on the left and see that in front of the x squared is a 5. On the right in front of an x squared is an a plus c. So that gives me an equation. I know what c is, which is 4. So we can solve and see that a is 1. In addition, I could look at the coefficients in front of x. On the left in front of x is negative 3. On the right, negative 2a plus b. And once again, you could stick in negative 1 for b here. I would have negative 2a minus 1 is equal to negative 3. Add 1. Negative 2 here. And then divide by negative 2, and I would get the same answer. So my partial fraction decomposition, 1 over x minus 1 over x squared plus 4 over x minus 2. Now let's integrate this. So we just found the partial fraction decomposition to be 1 over x minus 1 over x squared plus 4 over x minus 2. The integral of 1 over x is ln of x. The integral of 1 over x squared, so this is x to the negative 2, so we'll add 1 to the exponent, and then divide by that number, which will be dividing by negative 1. For this term, I'll let u be equal to x minus 2, so du is equal to dx. So this is plus 4 times the integral of 1 over u du. So we have ln x plus 1 over x plus 4 ln of u plus c. My final substitution then gives me the natural log of x plus 1 over x plus 4 times the natural log of x minus 2 plus c.